When you get all the information, what will you do with it?
When you get all the information, what will you do with it?
Well, we'll never be finished getting all the information. There'll be information coming out of this telescope for a really long time. But we'll try to answer all of those questions that I was talking about before. You'll make images of the sky. We'll try to understand how the galaxies are formed. We'll try to see if we can detect the gravitational waves that are predicted by Einstein's theory. There's just so much science to do. I couldn't even list it all if we spent all day here.
And one of the cool things too is that the reason, or part of the reason that so many countries want to be involved is that there's scientists in all those countries who want to use the information that we get from the telescope. So it's not actually just going to be us in South Africa. There are going to be people in the United States, and people in England, and people in Portugal, and people in Australia, and people in China, all looking at the information and trying to answer big questions and make new theories and see what we can discover out of it.
I think what's so nice about that is that's exactly what we're trying to do at schools. It's this whole collaborative learning, that you work together, you're not working in your isolated pocket and you don't share anything. It seems like what you're doing is, well, we're trying to copy a little bit of what you guys are doing on a very grand scale.
Yeah, and actually, funny enough, this is exactly what we do. So yesterday, well, once a week, Kim sits in a Skype session with people from
the Netherlands and like the UK and all over the world, and we talk about telescopes that we're working on right now.
Fantastic. You have questions?
Yeah. Have you found anything yet with the telescope?
Well, the A telescope isn't built yet, so we haven't found anything with that. But of course, we found lots of things already. I mean, we know now all these things about dark energy. We know that the galaxies are moving apart. Obviously, we found lots of galaxies. We found these things called black holes, which I think you know about. Some of you have asked questions about that. So we found all of that stuff already, which we didn't know was there before.
Right.
Do the telescopes rust?
Yeah, metal does rust, so it definitely will rust. But that isn't necessarily going to affect the way it forms, really. A layer of rust on the outside won't stop the metal on the inside from focusing the radio waves. So it'll still work, even if it's rusted, so long as it can still move.
Gemma.
Is it true that 95% of the universe is in dark matter?
I can't hear that question, sorry.
They were quite surprised about this fact yesterday, so they just wanted clarification on it, that 95% of the universe is actually dark matter. What people call nothing, that actually is most of the universe, or if you could antimatter.
There's 95%, there's something called dark matter and dark energy, and they're two slightly different things. So dark energy, when people say 95% of the universe is unknown, what they mean is that 95% of the energy that is supplied, that causes this expansion that I was talking about, isn't understood. So if you say, how much energy do I need to push apart all those galaxies, it's a huge amount. And if we look how much energy do we have, if I count up how many galaxies there are and how much force they can exert from their gravity, they only make up 5% of the amount that you need. That's what they mean when they say 95% of the universe is dark energy. Does that make sense?
So there's kind of missing energy. There's something that's creating movement, but they still don't know what that is.
That is, exactly.
Okay. They only know 5% of it so far. They don't know where the other 95% is coming from.
Yeah.
Is that correct?
That's correct.
Okay. Any adults with some questions?
How do they know it's not 5%?
How do they know it's 5%, says Mrs. Velkomut?
Well, because you say these are the galaxies, they're moving apart at a specific rate, so this is how much energy is required to move them at that rate, and how much energy can I see, how many stars are there, how much mass is there, and that's only 5% of the required amount.
Okay. Is that part of that Einstein's theory? What's that, E equals mc squared? That popped up yesterday into our debates, or not?
That is part of that, because that you can say E equals mc squared is how matter is converted into radiation. So the energy that I'm talking about is energy from gravity, pushing things apart, and energy from radiation, which is E equals mc squared, pushing things apart as well.
Okay. Right. Olivia.
Do you have any idea of how many galaxies there are?
Billions, trillions and trillions, and truthfully we don't know how many because, I mean, with our current telescopes you can't really see that far. So if we counted up how many we have now, there's billions of them, but there's still so many more to see because we haven't actually looked that far yet. That's why we want the SDA to look even further to see how many more there are.
Okay.
Emma.
Why did you call it the Meerkat Project?
So originally, the telescope was called the CAT array, or Karoo Array Telescope, because it's an array of telescopes connected together. And then when the South African government gave us more money to build more dishes, so originally it was just going to be the 7 dishes that are being built now. To build more dishes, they called it Meerkat, so that it would be more cat and telescope. Does that make sense?
Oh, that's the first time we've got it.